Hello everyone, welcome to Apex Mathematics. My name is Bino, and in this video we'll calculate the length of the curve of the following functions using the methods of calculus. Suppose we wanted to calculate the length of our function y is equal to f of x from the point A to the point B, where A and B are elements or coordinate of x. Then the length denoted by the letter S will be equals to the integral from A to B of the square root of 1 plus the derivative of the y with respect to x squared. So we differentiate that y, and this will be multiplied by the dx. Suppose on the other side we wanted to calculate the length from the point A to the point B of the function x is equals to f of y, where the A and the B are elements or coordinate of y. Then the length denoted by S will be equals to the integral from point A to point B of the square root of 1 plus the derivative of that x with respect to y squared, and this time around we integrate with respect to y. Suppose we want to calculate the length of the curve defined by the parametric equations x is equals to f of t and y is equals to g of t. Then the length denoted by the letter S of the curve will be equals to the integral from point A to point B of the square root of the derivative of the x with respect to t squared plus the derivative of the y with respect to t squared, and our integral will be with respect to t, where the A and the B are elements of t. For our first question, we have to determine the length of the curve x is equals to y to the power 4 divided by 8 plus 1 divided by 4y squared, and we are going to calculate the length between the points y is equals to 1 and 2. So we don't have to make y the subject of the formula. Instead, we use the formula S is equals to the integral from point A to point B of the square root of 1 plus the derivative of the x with respect to y squared, and our integral will be with respect to y, and A in this case is equals to 1 and B is equals to 2, and this we are given. We have to differentiate the x, but before we do that, we express it as x is equals to y to the power 4 divided by 8 plus, we take that y squared from the denominator to the numerator, and the exponent is going to change sign to -2, and this is divided by 4. And now we can determine the derivative of the x with respect to y. So the derivative of the x with respect to y will be equals to the derivative of that y to the power 4, which is 4 multiplied by y to the power 4, and we minus 1 from the exponent of y, and this is divided by the 8 plus the derivative of y raised to the power negative 2, which is equals to the negative 2 multiplied by the y raised to the power negative 2, and we minus 1 from the exponent of y, and this is divided by 4. From here we can simplify, so the dx divided by the dy will be equals to y to the power 4 minus 1 will be equals to y to the power 3, and the 4 divided by 8 is equals to 1 over 2, and that negative multiplied by that positive is negative, and we have y to the power negative 3, and the 2 divided by 4 is equals to 1 over 2. From here on, our formula for the length, the dx divided by the dy is squared, so we also have to square the derivative of the x with respect to y. So this will be squared, and what we do on the left hand side we also have to do on the right hand side, so we also have to square the right hand side. And from here we know that a minus b squared is equals to a squared minus 2ab plus b squared. So in the same way, the dx divided by the dy squared will be equals to y to the power 3 divided by the 2 squared minus 2 multiplied by y to the power 3 divided by 2 multiplied also by y to the power negative 3 divided by 2 plus y to the power negative 3 divided by 2 squared. From here we simplify, this will be equals to y to the power 3 divided by 2 squared, and that 2 and that 2 will cancel out, and y to the power 3 multiplied by y to the power negative 3 will also cancel out, and will be left with negative 1 divided by that 2 plus y to the power negative 3 divided by 2 squared, and this is equals to the derivative of the x with respect to y squared. And on our formula we can also see that we have the plus 1, so we are going to add 1 both sides of the equation, so we have 1 plus the derivative of the x with respect to y squared. This will be equals to y to the power 3 divided by 2 squared minus 1 over 2, and let's add the 1 next to the negative half, plus 1, this is plus y to the power negative 3 divided by 2 squared, and from here the 1 plus the derivative of the x with respect to y squared will be equals to the y to the power 3 divided by the 2 squared, negative half plus 1 will be equals to positive half, plus y to the power negative 3 divided by 2 squared. And it's important to realize that on the right hand side we have a perfect square trinomial, which we can express as y to the power 3 divided by the 2 plus y to the power negative 3 divided by 2 squared. This time around we have a positive in the middle, and this is equals to 1 plus the derivative of the x with respect to y squared. And inside our integral we had the square root of 1 plus the derivative of the x with respect to y squared, which will replace with this term on the right hand side. So we'll substitute the term on the right hand side inside that square root, and our a is equals to 1 and b is equals to 2 as we were given. So now we have the length denoted by s as equals to the integral from 1 to 2 of the square root of y to the power 3 divided by the 2 plus y to the power negative 3 divided by 2 squared and multiplied by the dy, and our s will be equals to the integral from 1 to 2 of, so the square and the square root will cancel out and we'll be left with y to the power 3 divided by 2 plus y to the power negative 3 divided by 2 dy. And from here we have to integrate, and our s will be equals to the 1 over 2 multiplied by the integral of y to the power 3, which is equals to y to the power 3 plus 1 divided by the 3 plus 1 plus that 1 over 2 multiplied by the integral of y to the power negative 3, which is equals to y to the power negative 3 plus 1 divided by negative 3 plus 1, and we have our limits as positive 2 and positive 1. So we simplify the s before we can substitute the 2 and the 1. So our s will be equals to y to the power 3 plus 1, which is equals to 4, and that 2 multiplied by the 3 plus 1, which is 4, will be equals to 8. We have y to the power negative 2, and the negative 3 plus 1 will be equals to negative 2. We multiply it with the 2, and this will be equals to negative 4, and our limits, the positive 2 and the 1. So now we can substitute the limits. So our s will be equals to, in the place of the y, we first start by substituting the 2, and this is raised to the power 4 divided by the 8 minus, in the place of the y we substitute the 2, negative 2 as the exponent, and this is divided by 4 minus 1 raised to the power 4 divided by 8 minus 1 to the power negative 2 divided by 4. And we use our calculator to compute this, and our s will be equals to 33 divided by 16, which in decimal form will be equals to 2,06 units. For our second question, we have to determine the length of the curve defined by the parametric equations x is equals to 3t and y is equals to 2t, and our t is from 0 to positive 1. For our parametric equation, the length will be defined by s, which is equals to the integral from a to point b of the square root of the derivative of the x with respect to t squared plus the derivative of the y with respect to t squared, and this is with respect to t. We have the x, which is equals to 3t, and our y is equals to 2t. We first start by differentiating the x with respect to t, and the derivative of that 3t is equals to 3, and inside the square root, the dx over dt is squared, so we also have to square the derivative of the x with respect to t. And what we do on the left, we do on the right. So even the 3 will be squared, and 3 squared is equals to 9. And on the other side, we have to differentiate the y with respect to t, and the derivative of that 2t will be equals to 2, and inside the square root, this is squared, so we also have to square our dy divided by the dt, so this will be squared, and what we do on the left, we do on the right, so 2 squared will be equals to 4. So the dy divided by the dt, we determined it as 4, and the dx divided by dt, we determined as 9. And our a will be equals to 0, and our b will be equals to 1, because our t is from 0 to 1. And substituting into the formula, s is equals to the integral from 0 to 1 of the square root of 9 plus 4 multiplied by the dt, and 9 plus 4 is equals to 13, so our s will be equals to the integral from 0 to 1 of the square root of 13, and dt, this will be equals to the integral of the square root of 13, which is equals to the square root of 13 multiplied by t, and our limit is from 0 to positive 1. So we are going to substitute the 1 and the 0, so our s will be equals to the square root of 13 multiplied by 1 in the place of t, minus the square root of 13 multiplied by 0 in the place of t, and our s then will be equals to the square root of 13 multiplied by 1, which is just the square root of 13, and 13 multiplied by 0 will be 0, and this will be equals to, in decimal form, 3,61 units. Thank you guys for watching up until this point. If you have any questions, feel free to leave them in the comment section below, and if you find these videos useful, consider subscribing, liking and sharing this YouTube channel with your fellow